Hey guys, my name is Rohit Singh and welcome to the channel Developer Geeks. Well, this is the current playlist of data structures and algorithm. In the previous video, we saw some introduction regarding data structures and we saw just that what is data structure and how the data are arranged. Well, in this video, we will understand what is a linked list, how the data and what is a node and every aspect and every terminology regarding the linked list. And we will practically see how you can implement and insert the data in a linked list. Well guys, now let's see by using animations how the linked lists are arranged, right? Basically, this is a node, right, which we create dynamically. The difference between static and dynamic is that in static you can't change the size or you can't add more elements to it, like an array, right? If suppose you are initializing an array like int a is equal to 1 2 3 4, so after runtime, so you can't increase the value or decrease the value of array, right? You can update but you can't increase if you want to add more elements. So that is called as a static, which won't change, but in dynamic we can change in the runtime. So in linked list there is a particular node that we arrange linearly. Basically a node we assign it dynamically. A node contains two parts. One is a data part, another one is a address part. Basically what this address is nothing but it will contain the pointer of what type of a node type, and it will contain the address of the next node. Now let's see an example. Suppose this is a linked list. The 27 is the data part, which is in the left. It can be in the right, left, it doesn't matter. Only thing it matters is that one section is given for the data, another section is given for the address, and the address is suppose a random address 1002. It's a random address, and in that particular address there would be a particular node. So the address is for a particular node. Now let's see another example, and it is not necessary that there should be only one data and one address, right? There can be many data, but you have to make sure that there is only one address given. You can see in the image that there are three different kind of datas. One is an alphabet, and another one is a character, another one is the integer data type, and the next section is for the address part, which will point to another node. Now let's see how the data, this particular data, is linearly arranged, and why we call this a linked list. Basically there would be a head pointer. There is always a confusion between whenever there's asked in interview that which is the first node, or if is head node the first node of a linked list or not. Actually head node is not the first node. Head node is the pointer. It points to the first node of the whole linked list. Now let's see what is a linked list. As I told you, head is a pointer. It will point to the node. Now this I have arranged the whole linked list in color format. So this particular node is in the format of red, and you can see the color of head is in red, so the block is in red. Now you can see the address in the red part is in blue color, therefore it will point to the blue color node, and it will have a data and a green node, a green address, and that will point to a green node. Then after it is having a yellow, you can see the green node is having a yellow address, so that will point to a yellow node, and similarly at the end it will point to a null node. So basically you can see it is not a circular arrangement, guys. It is a linear arrangement. Actually, if I change the arrangement and put it in a linear form, it will be in linear order, right? Actually, because of the lack in space, I did this, but you have to understand that how it is arranging itself. So what is happening is that head will point to the first, and the last element, the last node, will point to the null value. So traversing is nothing but traversing is something where you travel or you visit every single node. So if we have to travel from one node to the last node, what you will do is that you will, if you will start from the head node, you will see where the head is pointing, so that will be called as the first node, and you will check the address of the first node, which is pointing to 1002. That is nothing but the blue color, and then you will keep on doing that until and unless you reach a condition where the node's next value is a null pointer. Now basically what's happening is that if I tell you an example for a layman language, pointer is nothing but like a watchman, right? If suppose you are living in an apartment, so watchman is a pointer who doesn't have the value, but he knows the address of the person. Suppose the postman comes and he wants to post or to give a letter or some parcel at your home, so he will ask the whom? Yes, he will ask the watchman, right? So the watchman is having, you can see the different address of different nodes, so watchman is called as the pointer. Now a particular watchman or a particular pointer will have its own data type. That data type signifies that that pointer will only point to that data type. If suppose it's a pointer of integer, it will point to an integer data type. If suppose it's a pointer to string or a character, so it will point to a character data type. Similarly, head pointer, or you can see the 1002, 4002 and 7189 random numbers, these are the pointer of what type? The node type. Now what is node? Node is a user defined data structure that we create by using the struct variable in C++. Now you will briefly understand whole concept practically in C++ programming. Now let's jump into the compiler and let's see how you can create the whole linear data structure, that is the linked list. Hey guys, sorry for the disturbance. Actually, I have small announcement regarding this topic, that we are launching our own application, that is the Developer Geeks application, which is specially and it is specialized in data structures and algorithm. We will have animation aid, and we will have the coding part. You will be able to watch the video, and you can get the hefty definitions in an audio format, which it is not necessarily that you can read it, but you can even listen the definitions, and you will be able to see how the data is sorted, or how the data is formatted, how the data is transformed in very simple manner. So the application will be launched very soon. What you can do is that you can subscribe to the channel and click the bell icon so that you will be notified first. Now let's jump into the C++ compiler. Well guys, now let's see how does a linked list or a dynamic allocation works. Firstly, we will create a user defined data type by using the struct keyword. Basically this the syntax is like we will add a struct, and then after we will create a node of the same name. If I know you have heard of trees, I know you have heard of binary search trees or graphs, and to understand that major topic you have to understand the linked list. The reason is because those topics are on the basis of the linked list. If you understand this topic properly, then and only then you will understand trees and linked list, the implementation part. Basically, actually we have to remove since it's not a function, so we will remove that, and we will add a data part and a pointer part. Basically, pointers are something that points to a variable and it has a particular data type. To understand pointers briefly, you can access my C++ playlist in the I button. So we will write next pointer, right? Basically a node will have two things. One is the data and one has the address or the pointer to the next node, right? Now what we will do is that we will create a node called as head, and we will give the value of null. Basically, head is not a node, it is a pointer which is pointing to the first node, right? It is not the first node, it is pointing to the first node. Now what we will do is that we will create an array. Well, what is array? And how does it works? You can access my C++ video there. I have briefly explained the arrays, the concepts of arrays there too. What we will do is that we will add random values. I have no clue what I'm adding. I'm just keep on adding. I think it's enough. Now basically this would be the data part for the nodes, right? Now what we will do is that for trial, let's see is it printing or not. Basically this is a for loop, and auto is we call it as a storage class. I have covered the topic of storage classes. There are many storage classes, actually array, yeah, in the C++ playlist you can access that. Now what we'll do is that let's see out I. Now let's see that is that printing or not. Yes, you can see it is printing the values. Superb. And what we will do is that we will create a function of node type, and we will pass the integer data to it. Now what we will do is that this is the one of the important parts. Node star new node. You have created a new node like a head node, right? And instead of giving it null, you will dynamically allocate memory to it by using, you can use malloc, or you can use new, which is a keyword, new node. So it is basically an implicit way of allocation. It is done by the compiler, and if you use malloc or calloc, which is covered in the C++ part, that is done explicitly by the user's choice. Now since we have created the new data type, and we will assign the new node by using this pointer. The arrow is called as this pointer. So the new node's data is nothing but the data that we will pass in this function. So we have assigned that. Now what we will do is that we will new node next. The new node's next should be null. Yeah, the new node's next should be null. Then after what we will, the new nodes, what we'll do is that we will pass the head node also, and we will make the next part to the head part, and then we will equate the head part to the new node, and then we will return the new node. So how this function is working, we will see in the notepad. Now let's assign the values to it. We have created the head, and then after create we will pass the head, and then after we will pass the values, right? It will keep on passing till it reaches here. Now let's try to print. We will make a print function, void print, and then after we'll pass the head node. What we will do is that first we will create a temporary node and will equate to the head node. Basically now the head as well as the temp is pointing to head. The reason we created the temporary node, because this is a good practice actually, because if we pass the head node from 1 to the end, then if we want to again access the first node, so there is no pointer in the first node left if we traverse the head. So it is like a backup, right? Now what we will do, while temp is not equal to null, it will keep on traversing. Then after what we will do is that we will print the value of temp by using temp data and this pointer. Then we will update the temp value to its next value. So this is how you can print. Now let's call this function and we will pass the head pointer to it. Now let's try to run and let's see what it is, you can see that it is printing the value from the last to the first. The reason is because last is added at the end, right? So the head pointer is pointing to the 789 node. So guys, this is how you can create a node dynamically and you can print the values. Now let's see how you can print the whole thing reversely. If you want to print the reverse order, what we will do is that we will pass the head, and there is something called as the concept of recursive that you can find in my video. Well, what you will do is that you will say that if head is equal to null, then you will simply return. But if it's not, you will recursively called it. What you will do is that you will pass the next and you will print the data. Whenever you see this kind of a programming, actually you have to change the name. Let's write this print reb. Now whenever you see this kind of a program where there is a recursion and after that there is a statement, so this actually, okay, we have to change this to reb. Yeah, I think there's no error right now. Okay, now let's try to print, and we will pass the head, and within that we will add an handle to differentiate. Now let's try to print. Okay, there's no semicolon here. Yes guys, you can see. Okay, we will add a superb. Yes, now you can see it is printing in the reverse order. When I was talking about the recursion, right, when there is a recursion, it is basically stacking the whole data into a memory stack. So a stack basically works in the last in first out concept. So the last thing that is added in the stack will be printed first. So if you this is the actual, this is the actual data. So if this is added in the last, so it means it will print this in the first. So this is how the recursion works. I have briefly talked it in the series of C++. You can refer that. Well guys, this is how you can create a linked list, and we will see in the few chapters how you can delete a linked list or how you can update a linked list, and many problems of gate examination, and which will help you in understanding and coding for your placements too. Well, that is from my side guys. If you find this video informative, don't forget to like, share and subscribe to my channel. In the next video, we will learn some questions which is asked in companies and multinational companies like Google, Microsoft regarding the linked list. So stay tuned and see you in the next video.